Thank you for joining me. I am Mr. Ish. I hope everyone's doing well. Here we're looking at standard deviation and the concept behind standard deviation, particularly for a sample. When you're thinking about standard deviation, you're thinking about the dispersion or the spread of your values around a given mean or average for your sample. You are looking here at this list and you can see the list is not difficult. Hypothetically, if I have a list made of three numbers, 1, 5, and 10, and I'm comparing it to a list made of another three numbers, 4, 5, and 6, you know the lower list has a smaller spread. There's less dispersion of the values. The standard deviation here will be smaller. Here you have a larger spread. The standard deviation will be more in terms of the numerical value that you would obtain. But that's what you're talking about, the spread or the dispersion of your values around an average. You would have to start here by means of your sample mean. We have 8 values here. You can easily calculate the mean of your sample. It's not hard. Add those values, divide them by 8. 39 divided by 8, you'll have 4.875. When you're talking about the standard deviation of a sample, this right here is a symbol for it, a lowercase sigma. Your formula is going to be this. You're going to do the sum of all of these items here in the numerator, which is your individual values, their difference from the mean, and you're adding their squares divided by n minus 1, the total number in your sample minus 1. That's what it is. So when you lay it all out, your calculation is not that hard. You're basically taking each of those sample values, you're minusing them from 4.875. You can do 2 minus 4.875. You'll have here a minus 2.875 square plus, now you'll do 3 minus that. You'll have here a minus 1.875 square, and then 4 minus 4.875 minus 0.875 square plus, you see how we have 4 5's? I can simplify that. I can just do 4 times the difference squared. 5 minus 4.875, that's a 0.125 square plus 10 minus 10 is like an outlying value. It's quite far away from your mean, 4.875. This would be here 5.125 squared divided by n minus 1, which would be a 7. Now we can actually determine the sample standard deviation. It's a simple arithmetic computation here. Just square these, add them up, divide them by 7, do a square root. Don't forget the square root, because you can see here the formula is sum of those different squared divided by n minus 1, all within a square root. I'll post the value for you right here. Your sample standard deviation is a 2.356. Remember, don't make a mistake here in your computation, but we'll put the value here, 2.356. Now what we will do is analyze what that standard deviation means. You can analyze it in an easy way such as this. Put your sample mean here and it's a 4.875. Now look one standard deviation towards the right, which is positive. Look one standard deviation towards the left, which is a negative, and you know what the standard deviation is, 2.356. Add that to this and minus it from here and see what you get. By this boundary number 7.231, by this boundary number here, one standard deviation to the left is 2.519. Now we'll do 2 standard deviations away from either side of your sample mean, minus 2 standard deviations here, and let's do that. We can just add from here the standard deviation, we can just minus from here the standard deviation. This value here is 9.587. This value right over here, it's like a boundary value, is 0.163. Lastly, we'll do 3 standard deviations, plus 3 on this side. We'll do minus 3 on this side towards the left. Let's bring in these boundary values. It's important because it's part of the analysis. You can add from here and you can subtract from here. This here is 11.943. This here is minus 2.193. The general rule for a good sample is this. You will have 66 or 67% of your values within the first standard deviation. You'll have 95% within 2 standard deviations and 99% within all 3 standard deviations. That's just a general rule. You can keep that in your mind. But now, given this general rule, let's see how our values compare from this list. We have 2, 3, 4, 5, 5, 5, 5, and 10. When I'm looking at these boundary values, 2.519 and 7.231, I see a significant chunk of those values falling within 1 standard deviation, and those are all of these values right here. I have how many values? I have 6 values. These are 6 values out of 8, and that would represent a 75% of my values are here falling within 1 standard deviation, and the general rule is 67%. So here this list does not have too much of a spread in terms of standard deviation. Let's look at this value number 2. It's coming right here in between these two, so it's 2 standard deviations from your sample mean, but towards the left. And look at this 10. this 10 is coming between these two numbers right here, so it's 3 standard deviations away from the left. Generally with this specific list, you'll see one value which is within 2 standard deviations, one value which is within 3 standard deviations. These are 1 values out of 8, 12.5, 12.5. In this particular instance, we're seeing 100% of all our values are within 3 standard deviations. 75% of the values are within 1 standard deviation. You can do 75 plus 12.5 because 1 out of 8 is 12.5. You can see 87.5% of the values for this specific listing is within 2 standard deviations. So everything here is broken down for you. It is beneficial to do this type of analysis to see how far from your mean your values fall. We have a good chunk here: 1 standard deviation, a single value, 2 standard deviations, and a single value, 3 standard deviations. But that's all I want to present to you here. Have a good day.